Greece. Thank you very much, Mr. Karaklidis. Thank you very much, Mr. Balakakis, who allowed me to participate in this conference. And I would like to thank all of you for being here today. Especially right now, we're going to talk about water, because without water, there is no agricultural sector. Mr. Karaklidis mentioned the hydroelectric energy of Norway. No, when it comes to the management of surface water, there is also another very good example to a much drier area, Cyprus, which has developed a lot of reservoirs in order to store surface water, because we all know that surface water, if not stored, we cannot use it. We are a blessed land, a blessed country that has a lot of surface resources, but also a large aquifer. The aquifer alone is a reservoir, but we have robbed it. We have used it in a bad way. Here you can see the map of Thessaly with its three large basins, Pinios, Karla and Almiros. And they face similar and also some different problems. But which are those problems? The intensive and extensive cultivation of water-thirsty crops, the timely and place unequal distribution of surface water resources and water needs. There is a demand of water since agriculture is 90 to 95% for Thessaly, and it represents the total consumption of water. So you can understand we're talking about a lot of water. For Thessaly as a whole, it comes up to 1.2 billion tons of water. And this water is needed mainly from the end of spring till September, when there is no rainfall. And of course, water is produced in Pinios mountains and the other mountains of Thessaly. But we want to consume it here in the Thessaly plain. We don't have works for the utilization of surface water resources. Therefore, the easy solution have been to abstract water from drillings from our underground aquifer. Therefore, there has been an overuse, if you say, of the underground aquifer, which leads to a dramatic reduction of the water table, and also in the coastal areas such as Almiros. Unfortunately, I don't have a lot of time in order to show you results from the area of Almiros. It leads to the brackishness of the water, which means that sea is coming into the clear water, which means that we cannot use it for irrigation. Therefore, we have a lesser quantity and quality of water resources. And this is due to the wrong management of our water resources during all those years. You can see that the water table has been reduced, not only in central Thessaly, but also in eastern Thessaly. And in the lower graph, in the lower picture, shows us points of observation from the Karla Lake. Therefore, you can see that water has been reduced. And now we are going to see how the project of Karla helped the underground waters. We have run some models and a series of scenarios in order to understand what will happen. And we came up with 4 scenarios for the surface water resources. First of all, using the existing works. Second scenario is the existing works and proposed reservoirs within the water catchment of Pinios. The third scenario includes the existing reservoirs and the partial diversion of Acheloos, which means that we will divert 600 million cubic meters per year. And the last scenario is everything put together. When it comes to water resources, in order to allow them to be reborn, we have 2 scenarios. Either we will take 100% of the waters that can be renewed by themselves naturally, or 70% in order to leave some water that will allow the aquifer to be reborn on the long term. And we also run some water management scenario. The first demand scenario are based on the existing cultivations. The second is the improvement of the transport and distribution network of water, but also the change of the irrigation methods. And the third scenario is the fallow and the change of the 50% of the cotton crops and its replacement from grains. Those are the results concerning the 3 years that have been the wettest and the driest, let's say, years. I don't know if you recall, in 1980s we had a lot of rainfalls but a lot of drought. You can see that when it comes to the drier year, there is no solution. There are deficits. You can see in the middle that Acheloos River, with the obstruction of 600 million cubic tons per year, it somehow improves the situation. But if we will also see the scenario with the reduced needs, things get even better. So if we were to combine the second and the third demand scenario, which means to reduce waste in irrigation and change cotton crops and replace it with grain crops, and by also growing the reservoirs within the Pinios basin, you will see those results. So with the combination of those 2 scenarios, things get better. However, there is not a unique solution. We will have to combine various solutions and various options in order to overcome this obstacle. This is the relevant diagram with the scenario regarding Karla Lake. The red line represents the annual water balance for Karla Lake, and everything down the line is negative results, the deficits, and we can see the situation back then. If we were to combine the second and the third scenario, and we use only 70% of the naturally reborn renewable water resources and allow the aquifer to recover, you can see the green line, which gives us surpluses. And one might say this happened in the past, but what will happen in the future, in the years to come? According to the models, regarding Thessaly, we will have a reduction of the annual precipitation, an increase of the average temperature, an increase of the extreme phenomena of flood and drought, which means that the annual precipitation will be reduced, but there will also be times with floods and times with drought. A lot of extreme weather phenomena. And this, of course, will change the water balance, the natural balance. Due to the increase in the temperature, we will have a longer cultivating farming period and an increase in water needs and, of course, an increase in water deficit. This image comes from a recent study for the water balance for the Mediterranean area. When it comes to Greece, we can see that the reduction will be 200 millimeters per year. Now, when it comes to Pinios River, we have run three scenarios, a moderate, a middle scenario, and an extreme scenario, and the water balance will be reduced. According to the extreme scenario, we will do nothing. We will take no measures in order to mitigate CO2 emissions. And then things, of course, if we do nothing, things will become worse. The next is an example regarding climate change in the Karla Basin. The upper results are compared with the historic data that we have for the hydraulic heights of the Karla aquifer. Not only for the three scenario, and the red color means that the absolute height of the aquifer will be reduced and it will go under the levels of the sea. Now, let us see how the Karla reservoir has helped the situation, because the previous results were without the reservoir, without the use of reservoir. Things are now better, but the reservoir, given the climate change, cannot save the situation all by itself. Therefore, in order to conclude, water balance in Thessaly has been and will be deficit due to the lack of measures. Climate change will make things worse, and therefore we need to take immediate measures in order to reduce this deficit. People keep talking about the diversion of the Acheloos River. I have talked to you that those models have been run based on different data, and the diversion of Acheloos will not solve the problem. Therefore, we need to combine elements from various solutions. Measures should be taken. Which measures? We should increase the water that we can use by building new reservoirs within the water catchment, within the basin of Pinios River, and we should revisit the partial diversion of Acheloos River. And something which is very important, we should take measures in order to decrease the demand on water. We should restructure the crops, as we have heard in previous session. We should improve the efficiency of the existing networks for water transport and distribution, and we should also not only modernize the networks but also maintain them, because those projects are left on their own. We do not take measures in order to maintain them. New modern collective networks of irrigation Nikos didn't have the chance to show them, but new technology is there in order to save a lot of water. Last but not least, and taking in consideration climate change, one should adopt a modern, adjustable, holistic and collaborative water management. This new motto in water management is the adaptive water resources management, which means to not only implement a new project now for the years to come, no, we should build it and be ready to adjust. Thank you very much.